Hello everyone, my name is William Porter and I will be talking to you today about the synthesis of tamoxifen. It is a drug that has been called a cancer preventing drug. So this is a wonderful drug that can clearly help us in the future. If we look to the right of the screen, we see a three-ringed substance. We also see that it is an Z conformation. That will come into play later, as I will talk about. So why is it such a wonderful drug? The why. It is used in the treatment and prevention of breast cancer. It's actually used to treat receptor-induced cancer cells. So what this does is allows for the inhibiting factors of the growth promotion in estrogen receptors cancer cells. It can be synthetically created, which means it allows us to create this in a lab at all times. There is no biological or human DNA needed at the moment of creation of this drug. And then it also can be used in men. What happens in that case is that it can be used in cases of gynecomastia, which is also known as breast tissue in males. So that happens during treatments of prostate cancer when given estrogen as a form of treatment. So now we move on to who. We have the granddad, the grandfather, if you will, of this medication. It was originally created in the early 1960s by a man named Arthur L. Warpole. Okay. So it was also originally used instead of what we know it as today being a cancer prevention, but more of a post-sex contraception. So that, compared to today's medication, well-known medication is what is known as the morning after or Plan B pill. So they quickly had found out that this medication, that tamoxifen, is not able to give regarded as a post-sex contraceptive due to the side effects of increasing ovulation or fertility in large amounts of women. Our original drug name was actually called ICI 46474. So this actually had came to the name tamoxifen later, long time later. So the reason this medication was kind of shelved for a very long time was because it had those opposing effects than what it was originally used for. Now moving forward to the actual man who created this medication as we know it today. We move forward in 1972, a man named Craig Jordan began testing it on mice that had, by inducing inflammation into mammary gland tissue, and then treatment with tamoxifen assisted in the removal of the cancer cells or decretion in cancer cells. He had originally worked on estrogen receptors in mammary tissue, so working on the recognition of the receptors used in cancer cells, specifically located in the breast tissue, that allowed him to gain further knowledge and increase the need for the research of what we know today as this medication. It was originally used in the medication was originally used and recognized because it has such a large decrease in the receptor type of breast cancer, also known as estrogen receptor breast cancer. So in the 1980s, the drug actually became used as regular therapy, but it was originally approved by the FDA in 1978. In the 80s, when it was actually approved by the FDA as use for prevention of breast cancer, specifically the estrogen receptor breast cancer. Shortly after, it actually had become a change from an anti-estrogen to what is known as a selective estrogen receptor modulator, also known as a SERM. It also now goes by multiple different trade names or brand names, one being Nolvadex is widely known. So there are many different routes that we have that our medication can be synthesized. What happens in the body when this is synthesized, or after taking this medication, it allows for the metabolism inside the liver, is how this medication is delivered. So that is a large deal for how this medication will affect the body, where it goes, how fast it is absorbed. The actual synthesis of the tamoxifen. We see in this configuration here, we see our starting material added with a Grignard's reaction. Then an elimination reaction carried out to create our E configuration. Finally, it gets hit in removal of our alcohol group with the HCl and the creation of the ether functional group, as we can see in our top right product of that reaction. Finally, we get the addition and the removal of the OH after another attachment of a hydrogen, removal of that ether. We get an addition of the amine functional group, giving us the final product that is needed. As we look at this configuration, this is actually our E configuration, as said previously. It is actually shown that the E configuration will increase estrogen production. So this was actually the synthesis that was originally created and caused the fertility increases in women. So now as we look at, there are multiple different ways to synthesize this medication. But if we look at here, we look at a palladium catalyzed reaction, giving us our Z conformation. Z conformation is important because this is the actual conformation that allows us to treat the breast tissue that may be infected with cancer and prevention. As said previously, they had shelved it until 1972 when they were able to figure out that the Z conformation did what was originally intended. We see in this reaction here also that our 10-to-1 ratio between Z to E selectivity, which is very important as we want the effects of this drug to work how intended. This is another thing here we've just spoken about and proven that our Z versus E conformation is important. We see the Z conformation being our anti-estrogenic activity, while our E being estrogenic, increasing our estrogen. This is another technique used to be able to create our medication. We see here large amounts of things being added to create our final product, right? So we see that in our second step, the double bond here is actually on our C, our actual ethyl group that is hanging off, and the removal of it and move down to create our double bond in that Z conformation. So now we ask ourselves, why do we care about this medication? And why do we care about the synthesis of this medication? This medication is important because breast cancer in women is the second most common cancer, only following those of skin cancer. So that means that the discovery and the synthesis of the proper conformation will help thousands and thousands of women every year. In fact, on average, there are 250,000 cases of breast cancer each year. along with a little over 2,000 cases in men. The use of tamoxifen allows for the reduction of risk for further breast cancer, so treatment prevention for breast cancer by 49%. While we look around and we see that breast cancer is an increasing and a very difficult topic to talk about, understanding the synthesis and the products that are obtained by the techniques used by many men before us to create an ability to prevent and treat a life-altering disease. We see why the synthesis is such an important action. The Z conformation allows for that treatment of the medication that we need. So by synthesizing it properly, as shown in previous slides, this allows for the actual proper medication uses. Finally, we have our reference page. But thank you all so much for stopping by today and listening to a life-altering drug synthesis. Have a good rest of your day.